So everyone, in the next 15 to 20 minutes, we're going to talk about breaking MS Office code signing. And although what I'm going to show you today is a 5 years old vulnerability, it is still super relevant today because this territory of Microsoft Office has been vastly underexplored by security researchers. And I will give you some hints with some guarantees that you will find vulnerabilities in there. So why do we even care about breaking code signing in Microsoft Office? Well, one of the most important factors that people don't realize is that if a macro is signed and the certificate of that signer is in trusted publishers, that macro will then ignore any security settings. By default, no MSD, no marker of the web, and even if you have completely disabled macros in your macro setting, if the publisher of that signed macro is in trusted publishers, it will run. Which means that if we have a suspicion that there is some trusted publisher configured at our targets, and there are some common ones like Bloomberg, for example, which you see here, and there are some Microsoft certificates as well, which are quite often found by default in trusted publishers. If we can find content like this, and VirusTotal is your friend in hunting these kind of files, then we might have an opportunity to backdoor these files, which can help us with key factors like initial access and level movement. And I'm probably going to rant about Microsoft a bit, but let's be fair. The challenge that they have is huge. Because with traditional code signing of an executable, that's pretty easy, right? So you generate a hash sum over some content, like a VE executable, and you can then sign that based on public key crypto. But for macros and Office documents, that doesn't really work. Like, you cannot sign the whole document because the document might change while the macro itself, which you want to sign, is not changing. So signing the whole document is not an option. But then if you look at the macro container, I've given some presentations about that in the past. The macro container is a mixture of code and GUI settings. Like if you ever open the macro editor and you just rearrange some windows in there, the actual macro container in the document will change as well. Meaning that although you don't change any code, the macro container will change. So signing the macro container is not an option either. So what Microsoft did is they come up with this really complex algorithm, which is this, which they call content normalized data. It's in the VBA specification, and it's this algorithm where they extract which information is to be included in the input stream to the hashing algorithm. And this algorithm, it's a couple of dozen lines of code, and it's crappy as hell. And let's explore why it's crappy. One part of the algorithm is this. It says for each reference in this macro project, and macro project references are, if you go to view, project, references, you see them there. And if a certain reference is of type D, and I'll get to what that is exactly later, then the only thing that we do to the input stream to our hashing algorithm is to append 1 byte. So we're not doing anything with the integrity of that specific reference. We're just saying there is a reference, and we're going to sign based on that. So what actually is this reference type D? If you go look at the actual data which is there in the macro project, is this. What we see is a class ID, what we see is a file path, and what we see is a description over there. And if you're a bit familiar with this, you will recognize that this is a reference to a type library. And what a type library is, we'll get to that in a bit as well. So takeaway so far is type libraries in VBA projects are not properly protected from an integrity perspective in code signing for VBA. So to then understand how we can exploit this, we need to understand how the VBA runtime engine works. And if you've ever wondered, like, if I have a line like message box, how does the VBA runtime know what message box is, where it's coming from, and how it should run? This is a COM, Component Object Model. It's the Microsoft interface where they describe how code from one programming language can interoperate with code from another language. And COM is complex, but COM is quite easy at the same time, because in essence, COM is nothing other than virtual tables. It's just pointers to pointers to pointers, which in the end are functions which are going to be executed. So, in summary, COM is vtables. And now we are going to connect vtables, pointers to pointers to pointers, back to the scripting language VBA with its runtime engine. Because then, how does VBA know what message box is and which pointer to pointer to pointer to follow to run this code for message box? There's two ways to do that in COM. It's either via the iDispatch interface, which is heavily used in ActiveX, scripting languages, etc. And there's interface definitions. The iDispatch interface is a standardized interface in COM, where at runtime you can just query another COM object for, hey, which interfaces do you have? Which methods do they have? What kind of arguments do you expect for these methods? But this will be really costly at runtime, because you have to do many calls at runtime to understand another object that you're interfacing with. This is what we call late binding. And it's totally fine in scripting languages because they're slow as hell anyways. But within COM, we also have interface definitions, where there's files which specifies what the vtable looks like for this particular COM object, so that at runtime, we know this instead of that we have to do calls to the remote object to understand what it's like. And for this, Microsoft came up with the concept of type libraries. Type libraries are a proprietary file format from Microsoft. It has been reverse engineered, also based upon the ReactOS code. And you basically use the middle compiler to compile a interface definition language text file to this proprietary file format, which is the proprietary description of these vtables and pointers to pointers, etc., etc. And then eventually, if you have something which needs to understand this type library, like the VBA runtime engine, will do a load type lib, which is a Windows 32 API, and that will load the type lib and interpret it for you for the VBA runtime engine in this case. So now that we know that in a signed macro-based MS Office file, we can manipulate these type libraries, we can actually swap them out with references to our own, how can we practically exploit this? And we pursued a couple of paths for this. The first one is exploiting vtable pointers. Because again, in essence, a type library is pointers to pointers. As since we can mess up with this type library, that means that, for example, a call to message box, we could now point to another pointer. But with ASLR and control flow guard and all of the modern memory protections, this is not impossible, but it's hard. And it's particularly hard if you do not exactly know what kind of system you're going to land on. Is it Windows 10? Is it Windows 11? What kind of features will be enabled? So the next thing that we looked at is scriptlet monikers. It's a exploitation vector which James Forshaw made quite popular. And what James Forshaw discovered is that if you have a call to a load type lib, that you not necessarily have to input a file, but you can use a so-called scriptlet moniker, which is just a string which says script, colon, and then the path or the URL to a certain script. And if you feed that to load type lib, then you have script execution. So this would have been really trivial if signed macro file, we could just swap the type library references with the scriptlet moniker. However, because there has been a shitload of CVEs in the past which use this vector. In all of Microsoft Office, there is what they call the activation filter, the COM activation filter. You cannot activate the scripted moniker COM object in any Microsoft Office application. If you try it, it will just block it. So they completely ruled out this attack vector, and apparently it's not really used within MS Office for legitimate purposes because they just really block this out, scripted moniker. Another feature of type libraries is that you can specify a help string DLL. What is that? A type library can reference a DLL for localization features. If your type library in the VBA editor wants to show support in German or Spanish or Chinese or whatever, you can have a DLL generate these text messages on the fly. This works. So we can actually create a type library, put that in the macrosign file, have it reference a help string DLL, and then load our code by that. However, the code will only load if you go into the VBA editor and actually load the particular object, which will then try and show the help strings. No practical target will ever go there without a ton of social engineering. What worked in the end was no function definitions with DLL entry points. Within VBA, if you have a type library which says this particular function resides in this DLL, then that's a thing that we can use. So we can actually say we have a new function like outflank, and that function, it resides in a particular DLL. But then the big question is, how can we get our VBA code, which we cannot alter, we can only alter the type libraries, so call this particular function. And for that, we are going to another part of the algorithm. So, what does this part of the algorithm do? It removes any carriage return and line feed for the input to the hashing algorithm. Which is completely insane, because that means that from a code signing perspective, the upper code is the exact same as the lower code. Whereas I can clearly see that the upper code will call message box, and the lower code will call two functions, namely message and box. But from a code signing perspective, these are the same to Microsoft Office. So we can now have fun, and we actually introduced a new function, which is message, for which we can say, well, it resides in this particular DLL via our type library, and we can get our code called as soon as this is being done. However, in this case, we're lucky, because this macro has an auto-open event. What if we don't have an auto-open event? Then there's a slight bonus, because the specifications of everything within Office, they are archaic, and they have many references to double references for the same object, and this is one of the examples. So in the MS Office specification, they have a field which is called macro name, and they have a field which is called name, and both of them point to the same thing. So we have two fields which are the same thing. However, in practice, it turns out that the VBA runtime engine uses one of these fields to determine whether it is an actual auto-open event, and the other field is being used to actually call the method. So, if we have the one field named auto-open and the other fields named to our method that we want to call, then all of a sudden we have introduced a method with an auto-open event. And the cool thing is that this data is in the document itself outside of the macro container, so it is not signed at all. So what can we do with this? In practice, what we're going to do is we are going to compile this interface in a type library where we say we have this DLL where the function message and the function box are defined at this DLL. Compile this to a type library, swap out the type library in the original macro file, and by default there are always 3 type libraries in there, so there's always an opportunity to do this, and we will have successfully backdoors the file, which you see here with a very lame example with a call to malfunc1. So how did Microsoft solve this? They solved only one part of practical exploitation, is they introduced a setting which by default blocks type libraries from being loaded by untrusted network locations. That's the only thing that they did. And I'm totally not impressed by this. Because, well, somewhere in the Microsoft documentation, it says that a type library can be embedded in a compound document file, which is a Word file, or a PowerPoint file, or an Excel file. I have not found any practical implementations of how to do this, so I'm still exploring how to do it. But Microsoft themselves say that it should be possible. So it should be able to get the type library in the Word file itself, and that would bypass the fix. But there's many more stuff going on with the hashing algorithm and with the actual signing. One of them is that MD5 is still by far the most popular hashing algorithm that I've spotted for this. I've tested that collisions are already impractical. If you're a bit into hashing crypto, you know the pre-image resistance is still there for MD5, so that's not an option. But collisions with signed macro files, yes, definitely practical, possible. And in general, this stuff is complex. It's 20 years old, it's ambiguous, and there's hardly any public research going on in this territory of MS Office. So it's a perfect recipe for vulnerabilities. That concludes this very quick talk. I'm not going to do too much sales stuff, but if you're interested in a demo of our products and what kind of research of this that we have in our actual OST offering, then just drop by our demo station over there, and we can show you some of the good stuff. It was fast-paced. Hope you enjoyed it, and make sure that you got some takeaways to do some research yourself about this topic. Thank you so much.